Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello friends, a very good afternoon to all of you. Hi Vishnu, how are you? I hope everything is going good. So I think last class we had on Friday, I think, है ना? For heat transfer we had a class on Friday, and one class or second class of fluid mechanics we had on Saturday, है ना? So when start engineering mechanics? Vishnu beta, for engineering mechanics I'm not sure when the schedule will be out because I have not talked to mechanics sir, but most probably it will be out soon. But for now you can go with this thermodynamics. Thermodynamics is a very basic subject and it has no prerequisite. And I hope you have seen that in fluid mechanics also, I am telling you the prerequisites which are required. So you can do it. Don't worry at all. So, but I'm not sure. Frankly speaking, I'm not sure about engineering mechanics. But one thing I can do, so once the class gets over, just remind me. Okay? At the end of the class, remind me. I will ask the team, what's the plan for mechanics. Right now, the subjects which are going on, maths, aptitude, thermo, fluid mechanics, heat transfer, theory of machines, machine design, and SOM also. So these subjects are going on. So manufacturing, mechanics and industrial, that is not going on. Hai? So don't worry and I will check it out. So I think some students have already joined. So some people are there. A very good afternoon to all of you. आप लोग भी यार मैसेज वैसेज कर सकते हो कभी कभी, है ना? घबराना नहीं है. Okay, so I think we were discussing about the very basics of the subject, है ना? So do you remember what was the part that we did in the last class? What was the part that we did in the last class? Vishnu, anyone? What was the last that we discussed in heat transfer? Anyone? No? So I think we were talking about conduction, है ना? So we, in the first class, we saw the objective of the subject. Till now, I have not given you any kind of practical application. But believe me, this time we will discuss a lot of practical applications because we are starting early. So I have sufficient amount of time to go with. So I will try my level best that with everything you have practical applications. So we were into the chapter of introduction. We have seen the objective of the subject. So objective of the subject is to find out the Q dot value and to find out temperature as a function of position and time. This we did in the first class. And then in the next class, we started with the first chapter, that is conduction. So you guys told me that, sir, you guys told, guys, just 1 minute. Actually, it is the message is coming again and again, and that would be a disturbance in the class. Disturbance होगा, है ना? तो इसको off कर देते हैं. So we were talking about heat conduction. Hi Asha, very good afternoon. So you guys told me that, sir, when the transfer of thermal energy from one point to the other point is a result of molecular level activities, we call it as heat conduction. है ना? Which activities? Molecular level activities. And in molecular level activities, we have lattice vibration and free electron transfer in solid. We have diffusion and intermolecular collision in fluids. And then we discussed some basic ideas about these 4 points, that how these 4 points look like. है ना? But conduction is a result of these activities. Now we should remember that in any substance, so whether we talk of this solid, the lattice vibration is going on. The lattice vibration is going on. But if the temperature on left hand side, temperature on right hand side, it is equal. So basically the entire substance is at same temperature. There is no temperature difference. So when there is no temperature difference, lattice vibration will happen, but it will not carry heat, because then it is like balls of equal energy are colliding with one another. Correct or not? I hope I'm correct and I'm not doing any mistake. That when the temperature difference is 0, everywhere the temperature is same, lattice vibration will happen, but it is more like that the balls of equal energy are colliding, so they are not exchanging energy, so no heat transfer. But when here the temperature is high, here the temperature is low, then with the temperature difference, the same lattice vibration will help you carry heat. So heat transfer will come into picture. So activities always happen. But until and unless there is a temperature difference, we will not get heat transfer. So we saw this in the last class. And today we are going to continue with it. If we are lucky enough, we will start with practice questions also in today's class. So we will see where we are able to reach. Now the objective is that for conduction, how to write down the Q dot value. What do you want to write down? Q dot value, heat transfer rate. And that comes from something called as Fourier's law of heat conduction. So we will talk about that law today. But before discussing that law, there are certain important terms which we must be aware of. And these important terms will be used in other subjects also, like fluid mechanics, thermodynamics, strength of materials. So many of these terms will be used in other subjects. So it would be better if we go through these terms. Okay. So I can see that 6 people are there. So out of 6, one is myself. I am also watching the video on left hand side. And Vishnu and Aisha are there. Others also can interact in between. I don't want comments from you. It's like whenever I am asking whether this is clear or not, you should say yes or no. So there are some important terms which we will use throughout our syllabus, which you will see in every question of yours. And actually, those terms will decide how to solve a question, how to solve a problem. So those terms are actually important. What are those terms? So terms for this particular subject. So what are those terms? The very first term is steady, unsteady state. Very first term is steady, unsteady state. So any idea what is the meaning of steady state? What is the meaning of unsteady state? Any idea? Any idea? All of you? Any idea? Any idea? Any idea regarding steady or unsteady state? See, steadiness means constant with time. Constant with time. And unsteady means variable with time. So say for example, in this class, there are 2 students, brilliant students are there, Vishnu and Aisha. Okay. So what we have Vishnu and Aisha. So you can write this example also in your copies also. Now during the mid-semester exam, since you are in first and second year, hai na? So during the mid-semester exam, Vishnu got 50 marks, Aisha got 60 marks. Okay. And during final exam, Vishnu got 70 marks, but Aisha again got 60 marks. Okay. And let us say that in the next semester, what will happen? So second semester final exam. So in the second semester, both of you, since you are studying with me, both of you will get 100 marks. Okay? So bhaiya, Vishnu is performing like hell. His performance is improving so fast. Very good. Okay. Now guys, check. So mid semester final exam. So how much time period is there? 3 months. Hai na? So what we say? Time period. So there are 2 terms. One is time instant and other one is time period. What? Please note, there are 2 terms. One is time period, other one is time instant. 3 p.m. is a time instant. 4 p.m. is a time instant. So this we will show by T1. This we will show by T2. 3 p.m. is time instant and 4 p.m. is time instant. But the 1 hour between them, that will be called as time period. How do you write time period? You write it as delta t, that is final time minus initial time. This will be equal to 4 p.m. minus 3 p.m. that is 1 hour. Okay. Firstly, we should know how to define time in mechanics, in fluid mechanics, in heat transfer. How to define time. So there are two things. One is time instant and the other one is time period. So based on this example, tell me, this is a time instant or time period? Vishnu, Aisha, beta, based on this example, mid-semester is a time instant or time period? It is a time instant or time period? Just 1 minute. Time, nah, it is a time instant. Okay. Obviously, mid semester happens over a period of time. Mid semester happens in the entire 1 month, है ना? But actually, I wanted to say time instant. It is a time instant. So this is a time instant, particular time instant. This is a time instant. And between two time instants, there is a time period of 3 months. Okay. So these are time instants. Okay, Vishnu, I hope beta this is clear. Now what we will do, we will check the performance of Vishnu in mid-semester. 50, 50. So value of property at a time instant. Value of property at a time instant. Similarly, his marks in final exam 70. So value of property at another time instant. So for Vishnu, the marks are changing with the time. For Vishnu, marks are changing with the time. है ना? So what I will say the value of property for Vishnu is a function of time. Correct or not? Correct or not? Value of property for Vishnu is a function of time. So whenever the value of property for a point, not particle. Yes, Vishnu is like a particle, but we are studying the way in which we are studying, we will focus on points, and that I will elaborate in next 5 minutes. So when we say the value of property at a point changes with the time, that is called as unsteady state. That will be called as unsteady state. Okay? But suppose if I talk of myself, Pranshu, okay? Now I am an expert in this subject, so I will always get 100 marks, 100 marks, 100 marks, 100 marks. अरे यार मजाक मत उड़ाना, हाँ? ठीक है? मजाक मत उड़ाने लग जाना अब. Now for me, if someone checks for me, they will say the value of property for Pranshu for another point. The value of property for Pranshu is always same. It is not changing with the time. So property is not a function of time. Okay. So this will be called as steady state. This will be called as what? Steady state. So when the value of property changes with the time, it is unsteady. Value of property does not change with the time. It remains constant. Then it is called as steady. Okay. Now sometimes, so this is steady for me. Now sometimes apart from steady state, we also use a term uniform, non-uniform. Just give me a moment. I think I should remove my video. Hai na? So sometimes we also use a term uniform and non-uniform. So say for example, I have 100 toffees with me. How many toffees I have? 100 toffees with me. So when I will give 50 toffees to Vishnu and 50 toffees to Aisha. So my friends will say, this teacher is very good. He has distributed the toffees uniformly. Hai na? So equal values. So when Vishnu and Aisha have equal values of toffees, that will become uniform distribution. But suppose I give 60 toffees to Aisha and 40 toffees to Vishnu, then you will say non-uniform distribution. Hai na? So this means when 2 points have same value, that is uniform distribution, and when 2 points have different value, that is non-uniform distribution. But please note, when you want to understand steady or unsteady state, then what you do, you focus on one point. And for that one point, you make a video. So mid semester, final semester, second semester, है ना? So we will make a video for a point when you want to check steady, unsteady. But when you want to check uniform, non-uniform, then what you will do, you will take a photo. And for the mid semester, that is a time instant. So photo is a time instant, है ना? A photo is a time instant. So when you play a video in VLC and you press the pause button, that is a time instant. Now for that time instant, I will compare what is the value for Vishnu, what is the value for Aisha, what is the value for Pranshu. So I will compare different points. So 50, 60 and 100. So different points have different values. Different points have different values. So this will be called as non-uniform condition. This will be called as non-uniform condition. But guys, check, if I consider second semester, again I have taken a photo. I am talking of a particular time instant. So for second semester, what is the value of point? What is the value at point Vishnu? 100. What is the value at point Aisha? 100. What is the value at point Pranshu? 100. So all the points have same value. So this will become now uniform. This will become uniform. So please check. Please do let me know the example is clear. Example is clear. When you talk of steady or unsteady state, you focus on one point. And for the point, you see how the property changes with the time. But when you talk of uniform, non-uniform, you focus on one time instant, and for the time instant, you compare different points. Check or not? Yes or no? Yes or no? All of you? All of you? So you can make a short note. You can make a rough note in this. How to check a system is steady or unsteady. How to check system is uniform, non-uniform. Okay? So in rough only you can write down so that the same statement you can use in other subjects. Okay? So in rough only you can write down whenever we have to check steady, unsteady. Whenever you have to check steady, unsteady, you focus at a point, okay, and check how the value of property changes at the point with the time. Okay? So what you will write? You will write how value of property at a particular point. Value of property at a point changes with time. How value of property at a point changes with time. And in fact, for a better language, you can write how value of property at a point changes in a time period. Changes in a time period. So when I say changes with time, it means changes in a time period. Changes during a time period. ठीक है? ऐसे लिख लो. Actually मेरा English इतना strong नहीं है, तो मैं वो मतलब differences नहीं बता पाऊंगा meaning वाले. But this is the meaning. Okay? This is the meaning. So next point, uniform, non-uniform. Uniform, non-uniform. Okay? So in uniform, non-uniform, what we do? In uniform, non-uniform, what we do? We check that at a given instant of time, what are the values at different points? At a given instant of time, so during mid-semester, what were the marks of different students? So at a given instant of time, what are the property values at different points? What are property values at different points? What are property values at different points? Property values at different points. Please note, these small terms are very important if you really want to understand each and every question of heat transfer and fluid mechanics. These terms will be important over there. values at different points. Okay. Now you do one thing for me. Let us see an example, and in this example, let us find out whether the system is at steady or unsteady state. Okay. Let's see an example, and then we will find out whether the system is at steady or unsteady state, uniform or non-uniform condition. So say for example, this is the room. This is the room. And in the room, there is a window. In the room, there is a window in the middle. Okay. And maybe exactly at 11 a.m. Exactly at 11 a.m. I will take a photo. And the sun is somewhere here. Sun is somewhere here. Okay. So when I am saying 11 a.m., I am talking of time instant or time period. When I say 11 a.m., I am talking of time instant or time period. Check. 11 a.m., I am talking of time instant or time period. I am talking of time instant. Exactly at 11 a.m., I have taken a photo. So exactly at 11 a.m., this is the position of the sun. And because of the heat of the sun, if I will stand here, I will feel hot. So at this position, if I am standing, I will feel a temperature of 35 degrees Celsius. But the other person who is away from the window, he will comparatively feel cool. So at this point, the temperature is 30 degrees Celsius. So exactly at 11 a.m., when I am compare 2 points, exactly at 11 a.m., when I compare 2 points, their temperature values are different. So what is this? Steady, unsteady, uniform, non-uniform. Steady, unsteady, uniform, non-uniform. स्टडी अच्छा ओके लैग हो रहा है चैट और वीडियो में लैग हो रहा है बेटा यहाँ पे ना मेरे पास अपलोड स्पीड बहुत बढ़िया आ रही है एक्चुअली मेरे पास अपलोड स्पीड 50 Mbps की है जो 90 Mbps 80 Mbps भी जाती है तो इधर से अपलोड तो सही जा रहा है बेटा ठीक है तो दिस विल बी स्टडी अनस्टडी यूनिफॉर्म नॉन यूनिफॉर्म सर at a time instant, you are comparing 2 points. So you are not talking of steadiness, you are talking of uniformity. Aisha, very good. For a time instant, you are comparing 2 points. So you are talking of uniformity, non-uniformity. Rahman, beta check. At a time instant, we are comparing 2 points. So we are not talking of steadiness, we are talking of uniformity, non-uniformity. Now, at a time instant, since the 2 points have different temperature, so this will be non-uniform condition. If both points had same temperature, then it will be uniform. If the points have different temperature, then it will be non-uniform. Now, how do you explain this? So what you do, how do you explain this mathematically? So what you do, you take a coordinate system, okay? So this coordinate system will be x, y and z. So this point, it will become x1, y1, z1. What is the temperature? T1, 35 degrees Celsius. This point will be x2, y2, z2. What is the temperature? T2, 30 degrees Celsius. So different points have different temperature. Different positions have different temperature. So temperature will become a function of position. Temperature will become a function of position. So whenever temperature is a function of position, you say non-uniform temperature. What do you say? Non-uniform temperature. So Rahman, beta check. I have written over here 11 a.m. Exactly at 11 a.m. So you have pressed the pause button. So you are talking of time instant. Okay? In fact, remember like this now. When you compare 2 points for a time instant, we are talking of uniformity, non-uniformity. And when we check a point with the time period, when we study one single point, that becomes steadiness, unsteadiness. Now, let us elaborate this example a little. Now what will happen? So sun is not static, है ना? So sun will change its position. So from this side, sun will go up and then at the top and then at the bottom and then go down from morning to from morning to afternoon, evening and night, है ना? Then what will happen? Of course, when I'm standing near the window, initially the temperature was 35 degrees Celsius at 11 a.m. At 12 a.m. the temperature will become 40 degrees Celsius. So you will write at the same point where I'm standing near the window. So at 11 a.m. what was the temperature? 35 degrees Celsius. At 12 o'clock, what will be the temperature? 40 degrees Celsius. Then in the afternoon, that is 2 p.m., the temperature is maximum 45 degrees Celsius. And then again, the sun will start going down. So with the time, the temperature will decrease. So it will become 40. And then in the night, it will become 25. है So at a point, temperature is changing with the time. At a point, temperature is changing with the time. So now what you will say? You will say the property value at a point is function of time. Property, that is temperature, is function of time. So when you study a point with the time period, during a time period, we are talking of steadiness, unsteadiness. And since the property value is changing with time, it will become unsteady. It will become unsteady. Correct? Correct or not? Correct or not? And if this is correct, then tell me what will happen to this example. If this one is correct, then tell me what will happen to this example. So what I have, during the day, the sun is going up and it is coming down. So obviously, outside, in the morning, temperature will be less. In the afternoon, the temperature will increase. And during the night, temperature will again decrease. This is what will happen outside. But in the room, I have a high performance AC. I have a high performance AC is there. And in the AC, I have fixed the temperature 24 degrees Celsius. So in convection, I will tell you that generally, how many of you are from North India? How many of you are from North India? How many of you are from North India? So for North Indian people, at 100% humidity, the best optimum conditions are 22 degrees Celsius and 8 meter per second of speed. So according to our weather system, we have some optimum conditions. And North Indian people, the people who are living in Delhi and all, for them, these conditions are the best suited conditions. Similarly, there will be some conditions for people living in Mumbai where they feel the best. There will be some conditions for South India, some conditions for Kashmiri people. You know na, those people who live in Canada. So in Canada, the temperature reaches minus 25 degrees Celsius. And when the wind blows, the same temperature is like minus 40 degrees Celsius. So those people are used to very low temperatures, extremely low temperatures. When those people come in 10 degrees Celsius or 15 degrees Celsius, they feel hot. And people like us in 18 degrees Celsius, we are like, oh, such good weather is there. Let us bring out our sweatshirts. We live in Bangalore, so this is what happens in Bangalore. So different people have different conditions in which they suit best, in which they feel best. So similarly, with AC, we have fixed that the temperature must be 24 degrees Celsius. So high performance AC. So because of this AC, the temperature in this zone will always be 24 degrees Celsius. The temperature in this zone will always be 24 degrees Celsius. But if I stand away from AC, definitely I will feel comparatively warm. So temperature here is 30 degrees Celsius. But since this is a high performance AC, the temperature here will always remain 24. The temperature here will always remain 30. So you tell me what kind of system is this? Steady, unsteady, uniform, non-uniform. Steady, unsteady, uniform, non-uniform. Recycling in chemical process facilitates. बेटा मैं नहीं बता पाऊंगा क्योंकि मैं recycling वगैरह नहीं पढ़ाता हूँ. So what do you say? What do you say? Rahman, Aisha, Vishnu, all of you. What do you say? So steady, unsteady, uniform, non-uniform. So exactly at 11 a.m. if I compare 2 points. So what is the temperature at this point? 24. What is the temperature at this point? 30. So exactly at 11 a.m. that is for a time instant. If we compare 2 points, their temperature are different. Different positions have different temperature. So temperature is a function of position, right? And this will be called as non-uniform condition. What will be this? Non-uniform condition. Because different points have different temperature. Now do one thing, focus on one point and make a video of that point. So what will happen? For this point, temperature is always 30 degrees Celsius. Temperature is not changing with the time. So what you will say? For a point, temperature is not a function of time. So this will be steady state condition. Very good, Aisha. Very nice, beta. Very good. Very nice. So this is how you check whether a system is uniform, non-uniform, steady or unsteady. Now, what will happen in fluid mechanics when we want to check a system to be steady or unsteady, uniform, non-uniform? We talk of velocity vector. What you will talk about? Velocity vector. But in heat transfer, if you want to check a system is steady, unsteady, uniform, non-uniform, you talk about temperature. Okay? You will explain the system in terms of temperature. So is it clear to everyone? Is it clear to everyone? Any doubt is there? Is it clear to everyone? Any doubt is there? Any doubt is there? So we were majorly talking of steady unsteady state, है ना? We were majorly talking of steady unsteady state. So your final definition will be if the temperature is not a function of time. So when temperature is not a function of time, what will happen to this derivative? What will happen to this derivative? Temperature is not a function of time. So this derivative will be 0. So such conditions are called as steady state conditions. Such conditions are called as steady state conditions. And when temperature is a function of time, so temperature is changing with the time. So this derivative will become non-zero. So this will be unsteady state. This is going to be unsteady state. Acha. One question I would like to ask, because many times I have observed that students have a misconception about this. Does steady state condition exist in real life? Does steady state condition exist in real life? Anyone? Does steady state condition exist in real life? Anyone? Does steady state condition exist in real life? Yes, no. Many times students say, sir, steady state condition cannot be achieved. It's not like that. Focus on your electric bulb. Okay? Focus on your bulb. The light intensity which you are receiving, actually when you will see the bulb, you will feel some kind of chakachaunt, है ना? Because your retina had a small size and a very large amount of light is your retina had a big size, and when you see the bulb, very large amount of light will come from the retina and you will feel like shimmering and all that stuff, है ना? But if I consider the light which is coming from the bulb, so that intensity, is it constant with the time or variable with the time? I think I'm always receiving the same amount of intensity, है ना? I am always receiving the same amount of intensity from the bulb. So bulb is actually at steady state right now. The temperature of the gas in the bulb or the tungsten filament is actually constant right now. So what happens? Let me show you how it happens. And there is a very common example which people who live in North India have seen it. Not in South India, because in South India you do not use electric heaters. You use electric heaters in North India when there is winters, or in Himachal or in Dehradun, है ना? So suppose there is an electric heater. In the electric heater, there is a steel rod, and even South Indians know about it. है ना? We who live in South India, we also must have seen it somewhere. Okay? So there is an electric rod is there. So what happens? When you switch on the electric heater, the current passes through this rod. Okay? And initially, when it is switched off, the color of this, what is the color of this? The color of this is silvery, shining silver, gray. है ना? The color of this is like shining gray when the heater is switched off. So what will happen? When you will start passing the current through the rod, what will happen? The current will convert into heat. Now some heat will get stored in the rod, and the remaining heat will go out by radiation. So suppose you are giving 100 joule in form of electric current. So 40 joule will get 80 joule will get stored, and 60 and 20 joule will go out. Now because of the energy that gets stored in the rod, the temperature of the rod increases, and due to that the color of the rod also starts changing. So initially that rod, so from shining silver it will turn red, then from red it will turn orangish, then from orangish it will turn kind of yellowish, है ना? So temperature of the rod is increasing, that's why the color of the rod is also changing. But after few seconds, maybe like 20 seconds, the color will become constant. The color will not change. This means the temperature will also become constant. Actually, at that time, what happens? Whatever energy comes inside, all that energy goes out by radiation, and nothing is stored in the rod. Nothing is stored in the rod. समझ रहे हैं आप? समझ रहे हैं? So what happens? The amount of energy that goes out by radiation, it will depend upon the temperature of the rod. So as the temperature of the rod is increasing, this value will also increase, and a time will come when this value will become 100 joule. So you are supplying 100 joule, 100 joule is going out, and nothing is stored in the rod. So temperature will become constant. Temperature of the rod will become constant. So actually at that time electric heater is operating at steady state. So every system tries to achieve a steady state, whether it is a moving system, whether it is a heat transfer system, so steam power plant, AC, refrigerator, IC engine, or a moving body, or an object falling down in the sky. Every object, every system tries to achieve a steady state. It tries to achieve a final constant velocity. So in fluid mechanics, you will learn with me terminal velocity. So when an object falls down, it finally achieves a terminal velocity. If this will not happen, then whenever there will be hailstorms, the hail will fall on our head and we will die immediately. समझ लो? तो ये हम learn करेंगे. We will learn this. But is it clear from this example that a system tries to achieve steady state? Hi Satyam, क्या हाल है? Nice to see you here. ठीक है सत्यम, कल का क्लास क्लियर है? कोई डाउट है कल की क्लास में तो यहाँ भी पूछ सकता है, मगर यहाँ पे फिर हम एंड में ही डिस्कस कर पाएंगे. तो क्या है, दिस इज अ 150 डे कोर्स फॉर यूट्यूब स्टूडेंट्स. तो इसमें सारे सब्जेक्ट्स जो है पैरेलल चल रहे हैं. तो अगर अपने ओरिजिनल कोर्स में कुछ दिक्कत लगे तो इसको अटेंड कर सकते हो, अदरवाइज आपका तो सही चल रहा है काम. Aisha, Vishnu, Rahman, all of you. Clear? Is it clear? So please understand, steady state is possible in real life, and all systems try to achieve steady state. All the systems try to achieve steady state. So I would like a yes from Vishnu and Rahman also, so that I can move ahead, and I am sure and I'm sure that there is no doubt. Okay? So this was steady state. Now the next term that will be important for you guys, it will be the dimensionality of the problem. Whether the system is 1D, 2D or 3D. This will also be important. Whether the system is 1D, 2D or 3D. Now let me take the same example which I took in Satyam's class. So I said I'm a very big foodie and it is my dream that if I was not teaching, then there were only two possible occupations for me. One was army, other was working at a dhaba. So suppose I have a food stall or dhaba is there, and in that stall I am selling burgers, I am selling pizzas, ice creams and chocolates. Okay? So there will be a daily sale, है ना? So what will happen? If I want to calculate my daily sale, my wife is from management, so she's like business stuff, है ना? So she would want the daily sale. So I will tell her, भैया number of burgers this much into price of burger plus number of pizza this much into price of pizza, number of ice cream this much into price of ice cream plus number of chocolate this much into price of chocolate. So this will be my daily sale. Now daily sale is a function. Daily sale is a function. And this function depends upon some variables. Can you tell me what are those variables? Can you tell me what are those variables on which my daily sale depends? What are those variables on which my daily sale depends? What are the variables? What is the total number of variables on which the daily sale depends? So नहीं बेटा, ये भी यूलेरियन अप्रोच ही है, ये भी यूलेरियन अप्रोच ही है. हम टेम्परेचर को एज अ फंक्शन ऑफ पोजीशन एंड टाइम लिख रहे हैं, है ना? तो ये भी यूलेरियन अप्रोच ही है. हालांकि इनको मैंने अभी बताया नहीं है कि यूलेरियन लैग्रेंजियन अप्रोच क्या होता है, वो मैं इनको फ्लूइड मैकेनिक्स में ही सिखाऊंगा. Yes, very good, Aisha. Very good. So someone will say, sir, there are 8 variables. Someone might say that there are 8 variables. Number of burgers into price of burger. Number of pizza into price of pizza. So like this, there will be 8 variables. But actually, these are not 8 variables. These are 4 variables. How? Arey yaar, it won't be like this na. That person who came in the morning, I will give him the burger at 50 rupees. And the person who came in the afternoon, I will give the burger at 40 rupees. है ना? है ना? If I had good amount of money, I will give the burger free to everyone. But I have to feed myself also. But I am not biased. For every person, the price of burger is fixed 30 rupees. है ना? I am a good person, cheap person. So for every person, the price of burger is fixed 30 rupees. Price of pizza is fixed. Price of ice cream is fixed. Price of chocolate is fixed. So these are called as constants of the problem. What are these called as? Constants of the problem. Constants of the situation or phenomena. And these are called as independent variables. Because today 20 people came for burger. Tomorrow 25 people will come for burger. So these are the independent variables. These are what? Independent variables. Independent variables. Okay? So number of independent variables on which a function depends, that is called as dimensionality of the function. So this function is based on n1, n2, n3, n4. So this function is based on 4 variables. So we will call this as 4D function. What you will call this as? 4D function. So if you want to write down the definition in English, you can write the number of independent variables on which a function depends. That is the dimension of function. Okay? Now this is mathematical definition. This is mathematical definition. तो एक बार लिख ही लेते हैं, है ना? एक बार लिख ही लेते हैं. It would be good. The number of independent variables. The number of independent variables decides, on which the function depends, on which the function depends, which a function depends, is the dimensionality of the problem. Depends is the dimensionality of the problem. Okay? Now guys, please note, पहले लिख लो फिर नोट करते हैं dimensionality of problem. Okay, note it down. Now please note, so dimension, this word has different meanings in different situations. So as per the people who study physics, Michio Kaku, Neil D. Tyson, all these people, so Richard Feynman, Albert Einstein, for them, dimension means the variables which describe our reality, like this. Then when you will do fluid mechanics, there will be a chapter of dimensional analysis. As per that chapter, any physical quantity like mass, length, time, force, energy, temperature, or diffusion coefficient, any quantity is a dimension. So different cases have different definitions of dimensions. In our fluid mechanics or in heat transfer, this is the definition that we are going to use. The number of variables on which a function depends. Now check for temperature. Check for temperature. How you are writing the temperature? You are writing the temperature as function of position. So x, y, z coordinate and time. And obviously what this means? Obviously it means that, sir, this is the space. This space can be a wall. This space can be a room. So this is the space. In the space, if we take a point x, comma, y, comma, z, then at time instant t, what is the value of temperature at the point? This is what the function tells. But the function is dependent on how many variables? 4 variables. So this function must be a 4D function. This function must be a 4D function. But you know what? When we say independent variable, so independent variable is something which is under your control. If you like, you can take a higher value also, you can take a lower value also. Okay? So when I'm talking of x, I can stand on +5 or I can stand on -3. My choice. My choice, like Deepika Padukone. Similarly, if I talk of y, I can stand on +3 and -2 also. So x, y and z, they are in my control. But when I say time, time is not in our control. It is in the control of God. So, Bhagwan control karte hain usko. It always keeps on increasing. You can never go back in time. You always have to go forward in time. Bhaiya, if I have an interest, I will focus this thermometer at a particular point. So I have fixed the coordinates x, y, z. If I have an interest, I will fix the position constant. I will make the position constant. But with the time, you can never make it constant and you can never go backwards. You have to move forwards only. So time is not in our control. So we will not call it as a dimension. We will not consider this as a dimension. As a civil engineer, mechanical engineer, aerospace engineer, chemical engineer, you will not consider time as a dimension. But when physics people are solving this problem, they will call time as a dimension. So for us, time is not a dimension. Therefore, now the temperature function, is based on 3 dimensions only. What are 3 dimensions? X, Y, Z. So your better definition will be the number of space coordinates. Instead of independent variables, if I write down space coordinates, that would be a better definition. The number of space coordinates on which a function depends. Okay? So suppose temperature is a function of x only and time. So this will be called as 1D function because temperature depends upon only one coordinate. Temperature is a function of x, y and time. So it depends upon two space coordinates. So 2D. Temperature is a function of x, y, z and time. So it will be 3D function because it depends upon three space coordinates. Clear or not? Clear or not? Please check. I hope this is clear. Now check. As per the data given in a problem, as per the statement of a problem, how to identify whether the problem is 1D, 2D or 3D. Okay? As per the data given in the problem, how to identify whether the problem is 1D, 2D or 3D. Okay? Now check. Say for example, there is a cylindrical body and the cylindrical body is arranged in the Cartesian coordinate system. So please see, please check. This is important example. Please check. This is important example. Okay. So suppose this is the Cartesian coordinate system. This is your Cartesian coordinate system. You remember na Cartesian coordinate system? X, Y and Z. ठीक है जी? Now there is maybe a cylindrical body whose length is along the x direction. There is a cylindrical body whose length is along the x direction. So cylindrical body is arranged parallel to x direction. Okay? So can anyone tell me what is the plane of this? What is the plane of this surface? What is the plane of the side surface? So this is your cylindrical body. This is your x direction. This is your y direction and this is your z direction. So what is the plane of this surface? What is the plane of this surface? I think the plane is y and z. Hai? So the side surfaces are in yz plane. The side surfaces are in yz plane. Now suppose someone says that the left hand side surface of the body is maintained. Maintained means constant with the time. So steady state condition. So someone says the left hand side surface is maintained at a temperature of 80 degrees Celsius. And very good Aisha, very good. And the other side of the cylinder, so that is maintained at a temperature of 30 degrees Celsius. Okay, this is given in the question. So left hand side surface 80 degrees Celsius, right hand side surface 30 degrees Celsius. Now you check one thing. If I take 2 points which are parallel to z direction, so this point and this point, what is the temperature of 2 points? This is also 80, this is also 80, hai na? Bhaiya, it is saying the entire surface is at 80 degrees Celsius. It is written in the question, entire surface is at 80 degrees Celsius. So this point 80, this point 80. So both points have same temperature. So these points are along the z direction, but their temperature is same. This means temperature is not a function of z. Temperature is not a function of z. Similarly, let me take 2 points which are along the y direction. So this point also 80 degrees Celsius. This point also 80 degrees Celsius. So temperature is not changing along y. So temperature is not a function of y. Hai na? But definitely when I move along the x direction, here the temperature is 80 and here the temperature is 30. So temperature is changing along x direction. So temperature is a function of x. So what is happening? What is happening? Temperature is a function of only one space coordinate. So you will say this is a 1D system. This is a 1D system. Correct or not? Correct or not? Yes or no? Yes or no? Uniform along, not about, along. When we say about means rotation, around. About means around. Along, है ना? अच्छा, now do one question for me. Now do one example for me. So suppose there is a pipe and or there is a cylindrical container. That cylindrical container contains steam, and because of the high temperature of the steam, थोड़ा सा simple figure बनाता हूं, ऐसे ही ज्यादा ही बड़ा हो गया. And because of high temperature of the steam, the entire inner surface. So when I say the entire inner surface, so this is the inner surface, है ना? This will be the inner surface. So this entire inner surface is at a temperature of 90 degrees Celsius, and this is a pipe in Alaska. So in Alaska, we have the biggest pipe of the world, 800 miles long, which carries petroleum from one part of USA to the other part, and its internal diameter is 4 feet. Okay, 800 miles long pipe. Just imagine how much the pressure is required to make the petrol flow through this pipe. So this thing we will learn in fluid mechanics. But there is a pipe, and that pipe contains hot steam. Because of the hot steam, the temperature of inner surface is 90 degrees Celsius and the outer surface is exposed to winter condition. So outer surface is at 10 degrees Celsius. Entire outer surface is at 10 degrees Celsius. Now I am explaining this problem by a Cartesian coordinate system. This is the origin of the Cartesian coordinate system. This is your x direction, this is your z direction, and this is your y direction. Kindly tell me what kind of system is this, 1D, 2D or 3D. Please check and let me know what kind of system is this, 1D, 2D or 3D. What kind of system is this, 1D, 2D or 3D? बस अब थोड़ा सा बेसिक्स एक बार डेवलप हो जाएगा, then once we are developing basics, we will start introducing questions also and practical applications also. पर देखो हर सब्जेक्ट में कुछ prerequisites होते हैं और कुछ basics होते हैं. If you do not understand those basics and prerequisites, then you will not enjoy the subject later on. Because at various problems you will get stuck. At various point you will get stuck. So this is my agenda, that we have sufficient amount of time. So let us focus on prerequisites and basics first. So all of you. So what is this system, 1D, 2D or 3D? What is this system, 1D, 2D or 3D? So check. Firstly, let me do one thing. Let me take 2 points on the internal surface. Okay? आयशा बेटा 2D हो गया, 2D बन गया बेटा ये सिस्टम, बेटा ये 2D सिस्टम है. So let me take 2 points on the internal surface. What is the temperature here? 90. What is the temperature here? 90. So when I move along the y direction, temperature is not changing. So along the y direction, temperature is same everywhere. Temperature is uniform. So temperature is not a function of y. Rahman, beta 2D. Temperature is not a function of y. But let me do one thing. Let me take a point here and let me take a point here. So what is the temperature here? Inner surface 90 degrees Celsius. What is the temperature here? 100 degrees Celsius. Outer surface 10 degrees Celsius, outer surface. So when I move along the x direction, temperature is changing. So temperature is a function of x. Similarly, let me take a point here. Okay? So what is the temperature here? This is inner surface, so 90 degrees Celsius. This is outer surface, so 10 degrees Celsius. So when I move along the z direction, temperature is changing. So temperature is a function of z also. So temperature is not only a function of x, but a function of z. So this is a 2D system. What kind of system is this? 2D system is this. Okay? This is a 2D system. Got it? Khesar, very good. Acha, what about Vishnu? Vishnu, are you there, beta? Vishnu, are you there? Are you there? Now, one thing I would like to tell you, I hope you remember there are different types of coordinate systems, है ना? And actually, red not visible. Acha, ठीक है. So if red is not visible, I will make sure I'm writing with white or other color now. ठीक है? So one thing we need to understand that actually there are different types of coordinate system, है ना? I hope you remember you can use Cartesian coordinate system, cylindrical coordinate system, spherical coordinate system, है ना? So say for example, if you want to differentiate between them, just a quick difference between them so that if someone doesn't know, he or she can understand. So suppose I want to describe a point. What I want to do? I want to describe a point. That point can be described by Cartesian coordinate system, cylindrical coordinate system, or spherical coordinate system. How do you describe the point in Cartesian coordinate system? So what you do, first of all, you draw three perpendicular axes. Now these axes, they will become our principal directions. So one principal direction will be X, one principal direction will be Y, one principal direction will be Z. So for the point, how will you write down coordinates X, Y, Z? है ना? What is X? X is the distance of the point from the YZ plane. Y is the distance of the point from the XZ plane. And Z is the distance of the point from XY plane. I hope this is what a Cartesian coordinate system is. Am I correct? I hope this is what a Cartesian coordinate system is. Yes or no? Yes or no? Please do let me know if I am correct or not. This is Cartesian coordinate system. Okay? Now at the point, if there will be any vector, so in Cartesian coordinate system, this vector will have three components. One will be parallel to x direction, which we will denote by I cap. One will be parallel to y direction, which we will denote by j cap. And one will be parallel to z direction, which we will denote by k cap. है ना? So in Cartesian coordinate system, what are the principal vectors? I cap, j cap, and k cap. In Cartesian coordinate, the principal directions are I cap, j cap, and k cap. And any vector is resolved like this. This is your Cartesian coordinate system, है ना? Now the same point can be described by cylindrical system also. So who will tell me how do you draw a cylindrical coordinate system? What is a cylindrical coordinate system? Who will tell me what is a cylindrical coordinate system? Anyone? What is a cylindrical coordinate system? What is a cylindrical coordinate system? Anyone? Anyone? So actually, to use a cylindrical coordinate system, what we will do, again we will draw three perpendicular axes. What we will do? We will draw three perpendicular axes. Now one of the axes will be called as center line. What it will be called? Center line. And remaining two axes together, they will form the base plane or reference plane. Okay. In cylindrical coordinate system, we will have, first of all, we will draw a center line and then we will have a base plane or reference plane. Very good, Aisha. R, Z and theta. Now what we will do, the same point which was x, y, z in Cartesian coordinate system, the same point will be r, z and theta in cylindrical coordinate system as told by Aisha. What is r? What is z? What is theta? Actually, r is the perpendicular distance of point from the center line. R is the perpendicular distance of the point from the center line. Z is the perpendicular distance of the point from the base plane. Okay. Now what is theta? Actually, the two axes in the base plane. So one of those axes you take as a reference axis. Say for example, this I will take as a reference axis. This I will take as a reference axis. So angle between reference axis and R, that angle is called as theta. That angle is called as theta. So this is how you describe in cylindrical coordinate system. Why do we call it as cylindrical coordinate system? Because using R as radius, if you complete 360-degree angle of theta, you will get a circle. And using Z as length, you will complete the cylinder. That's why we call it as cylindrical coordinate system. समझ आया? Why we call it as cylindrical coordinate system? Because using R as radius, if we rotate theta 360 degree, we will get a circle, and using Z, we will get the length of the cylinder. So then we will get a cylinder. Correct or not? Cylinder of radius R and length Z. That's why we call it as cylindrical coordinate system. Correct or not, guys? Correct. All of you, please check. All of you, please check. Now, in Cartesian coordinate system, the principal unit vectors are I cap, j cap, and k cap. What are the principal vectors in this coordinate system? The principal vectors are, one vector is r cap. One vector is r cap. Okay. So r cap means, kindly check guys, is this color visible? I hope this color is visible. R cap means along the radius away from the center line. R cap means along the radius away from the center line. Z cap means parallel to the center line. And then there will be a theta cap. What do you mean by theta cap? Using R as radius, draw the circle. Using R as radius, draw the circle. So theta cap is tangent to this circle. Theta cap is tangent to this circle. So in cylindrical coordinate system, every vector will have three components. One is along the radius away from the center. One is parallel to the center line of the cylinder. And one is tangent to the cylinder. So every vector will have these three components. This is your cylindrical coordinate system. And RZ theta are the principal directions. These are your principal directions. Okay? Now, why did I introduce this over here? Because the same system, the same example, when I explain by Cartesian coordinate system, it becomes a 2D system. But the same example, when I explain by cylindrical coordinate system, it will become a 1D system. Let me show you how. Okay? So the same example of the pipe where the inner surface was 90 degrees Celsius and outer surface was 10 degrees Celsius. Okay. So the same surface of the pipe, now I will explain with Cartesian cylindrical coordinate system. Okay, na? So let us see how it will happen. So this is your outer surface. This is your outer surface. Entire outer surface is at 10 degrees Celsius. All the points of outer surface are 10 degrees Celsius. All the points of inner surface are 90 degrees Celsius. Okay. So what I will do, I will draw a cylindrical coordinate system. This will become the center line. And these two axes together, they will form the base plane. Okay. Now check. At any point, let me move. At any point, there will be three principal directions. One principal direction will be Z direction. One principal direction will be R direction. And one principal direction will be the tangent direction. That is along the circumference of the circle. That is theta. Correct? Now move along the Z direction. What is the temperature at this point? 90. What is the temperature at this point? 90. Bhaiya, both the points lie on inner surface. So temperature is not changing along Z. Temperature is not a function of Z. Okay? Now let me move along the circumference. What is the temperature here? 90. What is the temperature here? 90. What is the temperature here? 90. But yeah, all the points lie on the same surface. So what you have? Temperature is not a function of theta. Temperature is not changing along circumference. But if I compare this point, temperature is 90, and this point, temperature is 10. So temperature is changing along R. So temperature is a function of R. So temperature is not a function of Z and theta. It is only a function of R. So temperature is a function of only one space coordinate. Therefore, now it is a 1D function. Correct or not? Correct or not? So what will happen? The same problem, if I describe by Cartesian coordinate system, it will be a 2D function. So number of variables will be 3, temperature, X and Y. But the same problem, if I describe it by cylindrical coordinate system, it will be a 1D function, and there will be only 2 variables, temperature and R, which is solving more difficult. 3 variables or 2 variables? Where it is easy or to solve? 3 variables or 2 variables? I think solving 2 variables is always easy. Temperature and R. Solving it will be easy. So such system are better solved by cylindrical coordinate system. ऐसे systems जो हैं वो cylindrical coordinate system से ज़्यादा अच्छे explain किए जाते हैं. All of you clear or not? All of you clear or not? Please do check. Please do check. Clear or not? Clear? So whenever we are solving heat transfer in pipe, flow in pipe, it is better to use cylindrical coordinate system because the problem will be easy. The number of variables will be less. Now, since we are talking of coordinate system, let us talk about spherical coordinate system also. So, how do you show a spherical coordinate system? So, in spherical coordinate system also, just like Cartesian coordinate system or cylindrical coordinate system. Cartesian coordinate, अच्छा, थैंक यू आयशा. बेटा अभी तो बेसिक्स है. आई होप कि आप लोगों को और भी मजा आए. Actually, from some months, I have read some other extra subjects also of heat transfer and fluid mechanics. But I am not able to introduce that content in your lectures. एक तो आप लोगों को चाहिए भी नहीं, and it requires me also some time to frame that sort of examples. So I'm reading some additional subjects also like ocean dynamics, atmospheric dynamics, meteorology, propulsion systems. तो देखते हैं आपको वो सब एग्जाम्पल्स भी देंगे. मैं भी अपने ऊपर काम करता रहता हूँ. तो ठीक है. So here also we will draw three principal directions. These perpendicular lines are always there, whether it is Cartesian, cylindrical or spherical system. But the principal directions are different. In Cartesian coordinate system, these are the principal directions. But in cylindrical coordinate system, principal directions are R, Z and theta. Let us see spherical coordinate system. So in this system also, I will define a point. I want to define a point. So this is the point. Okay? Now, how will you do it? So first of all, you will join the point with the origin of the system. So this will be called as R value. Distance of the point from the origin. Now, using this R, using this radius, you draw a sphere. So I am showing only the hemisphere part. Okay. So using this, you draw a sphere. So obviously the point lies on the sphere. So what I can do, I can draw this arc from the top. Can I draw this arc from the top? Can I draw this arc from the top? है ना? So what will happen? this angle theta, that is the angle between the vertical line and the radius, this will be called as zenith angle. What is this called as? Zenith angle. So my friends who work in missile tracking and launching, so they use this terminology. Or the people who work in Air Force and they are using radar to track down a fighter jet or a missile, they use this terminology. 3 kilometers, zenith angle 40, something like this. ऐसे बोलते हैं वो लोग. So theta is called as zenith angle. Zenith angle. Okay? Zenith angle. Okay? Now what you will do, you will project this point at the base of the base plane. Okay? So there is a center line, there is a base plane. So you will project the point at the base plane. Can anyone tell me what will be this length now? Can anyone tell me what will be this length now? What will be this length now? So there is a triangle. I think we can see a triangle, and this angle is theta. So this side is r. So obviously this will be 90 minus theta, or this will be theta. I think this will become r sine theta. Yes or no? Yes or no? So if I call this as O, A and B, obviously OB is equal to R. Obviously OB is equal to R and OA is equal to R sine theta. Okay? Angle between the reference axis and OB or OA, that is called as phi. So phi becomes your azimuth angle. Phi will be called as azimuth angle. Okay. So here we are going to use R, zenith angle and azimuth angle. R, zenith angle, azimuth angle. Generally the radar systems, communication systems, missile launching and tracking systems, they are based on spherical coordinate system because it is easier to explain that way. ठीक है? तो हम कभी देखेंगे अगर time allow करेगा. Now in this coordinate system, what will be the principal vectors? What will be the principal vectors? So I will draw the figure again. So these are my initial perpendicular axis. This is the point. This is the point. What we will do? We will join the point with R. Okay? Now using R as radius, you can draw a hemisphere. So this is how the hemisphere looks like. Okay? Now the principal vectors. So one principal vector is along the radius away from the origin. So this will be called as R cap. The other principal vector is theta. So I hope you remember I have drawn a arc like this. है ना? So along this tangent that is in the vertical plane, you will have theta cap. And what you will do, you will draw a horizontal circle. You will draw a circle in vertical plane. So there are two circles. One circle is in vertical plane and one circle is in horizontal plane. So tangent to horizontal plane, that will become phi cap. So radius vector away from the origin, theta vector in the vertical plane and phi vector in the horizontal plane. So these are the principal directions. Clear or not? Clear or not? All of you? Clear or not? All of you? थोड़ा सा complicated है, spherical system, but we will use this in a very brilliant manner in thermal radiation chapter. So there I will explain it again and we will draw proper diagrams. But for now, just remember this much. Okay? Clear? All of you? Shall I move ahead? Shall I move ahead? So suppose this is the outer boundary of the bulb. This is the outer boundary of the bulb. Glass of the bulb. So glass has some thickness, na? So there will be an inner surface and outer surface. And at the middle point of the bulb, there is a tungsten filament, which is at very high temperature, 2000 degrees Celsius. So that tungsten filament is emitting very large amount of thermal radiation. Because of the thermal radiation, the entire inner surface is at 100 degrees Celsius and entire outer surface is at 50 degrees Celsius. Okay. So bulb is a spherical body and a spherical body. So do one thing, explain the system in Cartesian coordinate system and check what will happen. Explain this system in a Cartesian coordinate system, Cartesian coordinates, and tell what will be the dimensions. What will be the dimensions? What will be the dimensions? बाकी आयशा सच्ची बताऊं, अभी तो बेटा हम कुछ भी नहीं कर रहे. अभी देखना आप जब आगे बढ़ोगे तो आपको बहुत सारी नई नई चीजें मिलेंगी एंड आई नो यू गाइज विल एंजॉय. So tell me one thing, if I explain this system in Cartesian coordinate system, what will happen? What will be the dimension of the problem? What will be the dimension of the problem? Cartesian coordinate system. So sir, let us take this as x direction, and sir, this will be your y direction, and sir, this will be your z direction. Sir, if I take this point 100 degrees Celsius, if I take this point 50 degrees Celsius, so sir, when I move along x, temperature changes. So temperature is a function of x. Sir, if I take this point 100 degrees Celsius inner surface, if I take this point 50 degrees Celsius outer surface, so temperature is changing along y direction. And sir, similarly, if I take this point 100 degrees Celsius inner surface, this point 50 degrees Celsius outer surface, so temperature is changing along z direction. So this is becoming a 3D function. नहीं बेटे 3D बन गया बेटे, चेक कर 3D बन गया, spherical body है ना, spherical body है, 3D बन गया. Please repeat. अच्छा रहमान, just 1 minute बेटा, let me complete this and बस अभी ओवर होने वाला है आपका क्लास, क्योंकि आपका नेक्स्ट क्लास शायद थर्मो का है या मशीन डिजाइन का है, तो मैं ओवर कर दूंगा, तो मैं रिपीट कर दूंगा. So this is a 3D function. Please note, this is a 3D function. Okay? But when you will explain the same system by spherical coordinate system, you will explain the same system by spherical coordinate system. So this surface is at 100 degrees Celsius, है ना? This system is at 50, this circle is at 50 degrees Celsius. Inner sphere is at 100, outer surface is at 50. Now let me explain the same system by spherical coordinate system. So what I will do, first of all, I will draw 3 perpendicular lines. But when we say the principal directions, so one will be along the vertical plane, one will be along the horizontal circle, and one will be along the radius. These are the principal directions, right? So this principal direction is radial direction, this principal direction is theta direction, and this principal direction is phi direction, correct? Now check, you take 2 points along radial direction. So this point inner surface, temperature is 100, this point 50 degrees Celsius. So temperature is changing along R, temperature is a function of R. Now you take 2 points along theta. So what is this temperature? Inner surface 100 degrees Celsius. What is this temperature? 100 degrees Celsius. है ना? So temperature is not changing along theta. And similarly, you take 2 points along phi. What is this temperature? 100 degrees Celsius. What is this temperature? 100 degrees Celsius. Inner surface. So temperature is not a function of phi also. So temperature is now a function of only one space coordinate. So this has become 1D function now. So same bulb, when I explain by spherical coordinate system, it will be 3D. But when I Cartesian coordinate system, it will be 3D. But when I explain it by spherical coordinate system, it will be 1D. So which system is better? Spherical system is better. Okay? How many of you have got this and how many of you are facing a doubt? कोई प्रॉब्लम नहीं है. अगर डाउट आ भी रहा है, फर्स्ट टाइम कर रहे हैं, घबराना थोड़ी ना है. डाउट आ भी क्या तो क्या दिक्कत है ना? डाउट को क्लियर करेंगे. हाउ मेनी ऑफ यू हैव गॉट इट? हाउ मेनी ऑफ यू हैव गॉट इट? और एनी प्रॉब्लम इज देयर? Any problem is there? Aisha, Rahman, Vishnu, all the people who are watching, please do let me know. Any doubt, I will clear it out. Any doubt, I will clear it out. So, Rahman, beta, just a quick recap. So, what I was doing, I was explaining spherical coordinate system. So beta, in spherical coordinate system, you draw three directions first. These are perpendicular directions. अच्छा, ठीक है, कोई बात नहीं. Let's repeat, है ना? One quick recap. So what we will have? We have three perpendicular directions. These are always there, whether Cartesian coordinate system, whether cylindrical coordinate system, whether spherical coordinate system. Okay? But in cylindrical and spherical coordinate system, these are not principal directions. Okay? These are just for our reference, for making things easy. Now in spherical coordinate system, suppose you want to show a point. So this is a point over here. I want to find out the coordinates. So what I will do, I will first of all join the point with the origin. This will be called as R coordinate. Radius. This will be called as R coordinate. So R is the distance of the point from origin. Okay? Now what you do, using this R as a radius, you can draw a hemisphere. So maybe the hemisphere looks like this. Maybe the hemisphere looks like this. So this hemisphere has a radius R. Now have a look at one thing. Suppose this is point A and this is point P. So P will lie on the hemisphere. Now what you do, from P you draw a perpendicular on the vertical line. So this point will become Q. Aisha, अब देखना बेटा, अब समझ आ जाएगा. ठीक है? Now you will get it. You will get a perpendicular line Q. Now obviously this angle I was calling as theta. So this is the other coordinate. This is what? Other coordinate. And what I can do, if I keep theta to be 0 degree, I think I will get this line. This will happen when theta is 0 degree. And if I keep theta as 90 degree, I will get this line. Correct or not? So when you vary theta from 0 to 90 degree, actually you get an arc like this. Correct or not? Correct or not? When I am varying theta from 0 to 90 degree, I will get an arc like this. So basically the same point will move from top to the base. So you will get an arc like this. And in the triangle OPQ, PQ will be r sine theta. PQ is r sine theta. But this is in horizontal plane. So using PQ as a radius, I can draw a horizontal circle. I can draw a horizontal circle. Okay? Now what happens? At the point P, there are three principal directions. What are those directions? One is along the radius. One is along the radius. So this will become your r cap vector. One is tangent to the vertical arc. This will become your theta cap vector. And one is perpendicular tangent to the horizontal circle. This will become your phi cap vector. So is there no ball type body over here? Just give me a moment. There must be a ball over here. Just give me a moment. Just give me a moment, guys. Let me check if any ball is there. I will show you. Just give me a moment, guys. Okay, so I got some old watermelon. Okay, now check. So this is the sphere we are talking about, है ना? X direction, Y direction, and Z direction, है ना? These are directions, but in spherical coordinate system, they are not reference directions. Now at the point, the point is at a distance r from the center. But can you see there is a vertical arc also? है ना? There is a vertical arc also. So tangent to the vertical arc, that is theta cap. But this theta cap is in vertical plane. है ना? It is inclined and it is in vertical plane. Now at the same point, I will draw a horizontal circle. For this horizontal circle, the radius will be r sine theta. And theta cap will be tangent to this circle. So theta cap is in horizontal plane. So phi cap. So theta cap in vertical plane and phi cap in horizontal plane. And r cap is perpendicular to them both. That is, r cap is perpendicular to the surface. So these are three principal directions. So when you say theta cap, you move along the surface but in vertical plane. When you say phi cap, you move along the surface but in horizontal plane. And when you say r cap, you move away from the surface. समझ रहे हैं? So theta and phi are along the surface, but r is away from the surface. Clear or not? Is it clear? बड़ा बेकार मेलन भेजा यार ये बिग बास्केट वालों ने. ठीक है. Is it clear, all of you? Is it clear? Or still doubt is there? Still there is a doubt? Please do let me know. Please do let me know. Now in my example, what was happening? What was happening? The entire inner surface was at 100 degrees Celsius. So if I move along the surface, whether in vertical plane or whether in horizontal plane, what is the temperature here? 100. What is the temperature here? 100. So temperature is not changing with theta. What is the temperature here? 100. What is the temperature here? Phi. 100. So temperature is not changing with phi. But when you move away from the surface, you will reach the outer surface. Outer surface is at 50 degrees Celsius. So temperature is changing along R. Correct? ठीक है ना? So temperature is a function of R. So whenever you are describing such kind of spherical bodies like sun, how much is the heat emitted by the sun and how much heat will be received on earth, we are going to use spherical coordinate system. समझ रहे हैं? In thermal radiation, you will observe spherical coordinate system is the best. In an AC example, your answer is steady state. It is varying with time, sir. Vishnu, beta, I said you assume that you have a perfect AC. And in the perfect AC, you have fixed on with the remote 24 degrees Celsius. Okay? You have fixed. So since it is a perfect AC, it is a high performance AC. So what will happen? The locations which are near the AC, that will always be at 24 degrees Celsius. And the locations which are away from the AC, they will always be at 30 degrees Celsius. So when I am standing here, the temperature is always 24 degrees Celsius. So temperature is not changing with time. Temperature is not a function of time. Na? So steady state. But if you compare this point and this point, 2 points have different temperature. So temperature is a function of position. So this will become non-uniform condition. This will become non-uniform state. Okay. Okay. So I think time is already over. But ठीक है, आज के लिए इतना ही करते हैं. I don't want to be hindrance in your other classes. So what we will do next time, we will continue this. We have understood what is steady state, what is uniform, non-uniform, what is 1D, 2D and 3D, and what are the three coordinate systems. Initially for few days we are going to use planar systems only, Cartesian coordinate system only. Then we will start using cylindrical coordinate system. Then we will start using spherical coordinate system. Your thermal radiation will entirely be based on spherical coordinate system. So obviously when I will start those topics, I will give a quick revision of these, and then we will draw some better diagrams also. आयशा बेटा, एक्चुअली मेरे पे भी कुछ लिमिटेशन है, तो क्योंकि दूसरे सर की भी क्लास होती है ना, तो मैं उसमें इंटरप्ट नहीं कर सकता. तो करेंगे, टेंशन नहीं लो, अपना ब्रेक लो आराम से, और कल हम कंटिन्यू करेंगे. कल हम पढ़ेंगे एफएम और परसों हम पढ़ेंगे एचटी. एक दो दिन रुक जाओ, मैं टीम से बात करता हूँ और कोशिश करते हैं अगर मेरा टाइम हाफ एन आवर अर्ली हो जाए तो. उससे क्या होगा, हम हीट ट्रांसफर और फ्लूइड मैकेनिक्स दोनों की क्लासेस जो हैं वो 2 बजे कंडक्ट कर लेंगे. 1:30 हो जाए या 1 o'clock हो जाए तो हम कर सकते हैं. बस मुझे चेक करना होगा कि आपकी मैथ्स की क्लास का टाइमिंग क्या है, उस हिसाब से. ठीक है, तो चलेगा, ऐसा चलेगा. टेस्ट बुक बेटा पहले भी बताया था. इफ यू आर बिगनर, so for beginner, DS Kumar is there and PK Nag is there. ठीक है, तो PK Nag is good for convection, very good for convection, but you will be able to do convection from here only if you have done fluid mechanics properly. And DS Kumar is very good in terms of numerical problems because very good number of solved examples is there. If you are through these books, then you can go for Sengel, you can go for Leonhard, or Cropra, और हॉलमैन. कोई भी बुक ले सकते हो, ठीक है, कोई भी बुक ले सकते हो, बट फर्स्ट फोकस ऑन दीज बुक्स and then on these books. Okay, I think Incropra is better as compared to Sengel, but Sengel has comparatively easy language. लैंग्वेज उसका बहुत इजी होता है, उसमें भी प्रैक्टिकल एग्जाम्पल काफी होता है, तो पढ़ने में मजा आता है. तो कोई भी बुक फॉलो कर सकते, ठीक है. बट फॉर बेसिक अंडरस्टैंडिंग एंड फॉर कॉम्पिटिटिव एग्जाम्स, these books are sufficient. And your notes will actually have more content than these books. Believe me, your notes are going to have more content than these books. So you need not worry about that. But yes, if you want to study yourself, then you can go for them. Vishnu, it's like better for very basic beginning, DS Kumar is sufficient. Theory also and questions also. DS Kumar has more number of solved examples as compared to any other book. So when you want understanding of something, you need theory also, you need questions also. Now if solved examples are not there, students get confused whether my answer is correct or not. So DS Kumar is helpful in that case. इसलिए मैं बोलता हूँ ये बुक अच्छा है. मैंने तो बोला ही बेटा कि you will have more theory than books. So you can simply focus on questions. मैंने पहले ही बोला बेटा, आपके पास ज्यादा ही थ्योरी होगा, आपको कोई टेंशन लेने की जरूरत नहीं है. आपको मतलब कि इन कंडक्शन एंड रेडिएशन यू नीड नॉट वरी अबाउट दिस. ठीक है, इन बुक्स की भी टेंशन लेने की जरूरत नहीं है जब कंडक्शन और रेडिएशन की बात करें. और मैं आपको कन्वेक्शन भी पढ़ाऊंगा, मगर अलग तरीके से पढ़ाऊंगा, तो आप बिल्कुल टेंशन नहीं लो. ठीक है, मैंने ऑलरेडी ये बुक्स पढ़ी हुई हैं, टेंशन नहीं लो. हाँ, so मतलब that's why I said ना, for beginner level, for your semester, for basics, very basics, and for competitive exams, these books are really good. But if you want to dig more, ऐसा है. ठीक है, हर बुक का अपना एक फायदा होता है ना. इन बुक्स का लैंग्वेज इजी होता है. These books have easy language comparatively, so more easy to understand. these books use Indian notations, so more easy to develop habit. ऐसा है, ठीक है. चलो फिर guys break ले लो, have some tea and go for the other class, ठीक है. But please note, revision is very important. Even if we are doing small amount of work and we are not revising it, the next day you will forget it. Revision is very important. तो आप ना revise करो. कल हम मिलेंगे और कल हम fluid mechanics के prerequisite continue करेंगे. Day after tomorrow you will have your class on heat transfer. So we will discuss two more important terms which are short terms. One is no internal heat generation and the other one is homogeneous isotropic material. Then we will write down the Fourier's law and see electrical analogy. So good topic. In electrical analogy, there is good number of questions that comes in semesters, that come in exams, that come in competitive exams. Even in competitive exam, it is almost asked every alternate year in every exam. तो अच्छा टॉपिक है, ठीक है. जाओ फिर मिलते हैं, बाद में मिलते हैं. See you tomorrow. Bye.